All right, let's dive into a shift that is completely redefining one of the most important skills out there, writing code. And I'm not talking about simple auto-completion. We're talking about the rise of actual AI software agents, AI that can build, test, and, even think for itself. Let's get right into it. Come on, if you're a developer, you have definitely had this thought, probably late at night, staring at a bug that just won't die. What if your dev environment wasn't just a tool, but a partner, a collaborator that you could give a high-level goal to and it would just handle it? Well, guess what? That future is getting here a whole lot faster than you think. For the last few years, we've gotten pretty used to AI giving us a little help, right? Finishing a line of code, suggesting a function. But that was just the warm-up act. The real story, the one we are unpacking today, is this incredible jump from being a passive text predictor to being an active decision-making agent that can actually reason, plan, and execute on its own. And look, this is not some slow, gradual shift. It is an absolute explosion. Just think about it. Back in 2021, we had these huge breakthroughs like AlphaCode. By 2023, the field was already getting crowded. And now, the pace is just relentless. New, more powerful models are dropping constantly. The speed of progress here is, well, it's just staggering. So what is actually powering this incredible acceleration? Well, to figure that out, we've got to look under the hood. We have to look at the AI's brain, its architecture, because this is where a really fundamental, game-changing shift has happened. So you used to have these traditional, dense models. The way to think about this is an AI where the entire brain lights up to solve every single problem, no matter how small. Super powerful, sure, but incredibly inefficient. The real game changer is the shift to what's called a mixture of experts, or MOE, and it's a totally different way of thinking. Instead of one giant brain, you have a whole team of specialists with a smart router that sends each task to only the relevant experts. And this MOE architecture is really the secret sauce to unlocking massive scale with surprising efficiency. For example, a model like DeepSeek-Coder v2 might have a whopping 236 billion total parameters, which is just colossal. But for any one task, it only activates about 21 billion of them. It's kind of like having an entire university faculty on speed dial, but you only call the 2 or 3 professors who are the world's leading experts on your very specific question. And the innovation here is not slowing down at all. We're already seeing even more advanced designs, things like diffusion models that build code through this process of iterative refinement, almost like a sculptor chipping away at a block of marble. And then you have hybrid architectures that mix and match different approaches to get the best of all worlds. The architecture itself is a frontier that's just evolving like crazy. So, okay, you've got this incredibly powerful and efficient architecture. But how do you turn it from a blank slate into a master programmer? Well, you need data. A mind-boggling amount of data. So what kind of scale are we talking about here? Well, just one of the key data sets used for training contains 900 billion tokens of code. 900 billion. That's pulled from sources like GitHub, and it covers over 600 different programming languages. This is the massive digital library that these AIs are studying. And the training isn't just dumping data in. It's this really sophisticated 4-stage process. First, in pre-training, the model just soaks up all that raw code, learning grammar and patterns. Then it specializes on more specific kinds of code. After that, it's taught how to actually follow instructions. And finally, through reinforcement learning, it gets aligned with human preferences for safety and quality. It's a real journey from just raw knowledge to a truly refined skill. Okay, so we've got a powerful architecture and this intense training process. And all of that enables the most important transformation in this whole story, the leap from simply predicting the next word to actively solving problems. You know, one of the key insights from the research just nails this shift perfectly. It's that when you combine these powerful models with tools and a feedback loop, they stop being these passive autocomplete engines. They actually become agents that can make decisions. And this is what separates a true agent from a simple code generator. It isn't just spitting out text. It's an autonomous system. It can understand a high-level goal, create a plan, and then use the actual tools a developer would use, a terminal, a code editor, even a web browser to look up documentation to get the job done. Their workflow basically operates in a closed loop. So an agent gets a request, something like fix this bug, First, it plans a series of steps. Then it retrieves the right files from the code base to actually understand the context. Then it edits the code. And here's the crucial part. It verifies its own work, running tests to see if the fix actually worked. And if it didn't, it iterates, it learns from its mistake, and it tries again. The scope here is just massive. We're not just talking about writing a new feature. These agents are being built to participate in every single stage of the software lifecycle, from helping to define the initial requirements, all the way through development, testing, long-term maintenance, and even managing deployment pipelines. The whole shebang. But of course, giving an AI the keys to your codebase and letting it use all these developer tools, well, that raises some pretty serious questions. With this new level of autonomy comes a completely new class of risks and vulnerabilities that we have to address head-on. Yeah, the security landscape changes completely. It's not just about preventing the AI from writing insecure code anymore. Now attackers can try to manipulate the agent's reasoning. They can try to subvert its workflow to make it misuse its own tools, or, and this is the worst-case scenario, trick the agent into executing code that lets it escape its secure environment and attack the system it's running on. But the good news is, the security field is moving just as fast. The response is a multi-layer defense. So layer 1 is containment. Run the agent in a secure, isolated sandbox. Layer 2 is proactive validation, using other AIs to review the agent's code and plan before it ever gets executed, kind of like a peer review for AI. And the third layer is real-time oversight, a guardian agent that watches the main agent and can step in to stop unsafe actions as they happen. This whole strategy is called defense in depth. It's not about finding one single silver bullet. It's about creating this robust security posture, where multiple layers of defense all work together to manage risk and make sure the agent behaves exactly as intended. So once we get a handle on making these agents safe and secure, what does the future of building software actually look like? Well, the research is uncovering some really fascinating and kind of non-obvious complexities. This leads to a really interesting question. Are all programming languages equally difficult for an AI to learn? The data says pretty clearly no. This irreducible loss is basically a measure of how complex a language is. And surprisingly, the flexible syntax of a language like Python actually makes it harder for an AI to master. On the other hand, a more strictly typed language like C# is fundamentally more learnable. And the nuance here goes even deeper, because the best way to get an AI to master a language is also different. For Python, performance gets better when you just throw more and more data at it. But for a language like Go, the model actually benefits more from just being bigger and more powerful. So the best training strategy literally depends on the language you're targeting. So when you put all of this together, the long-term vision becomes pretty clear. We're heading towards a future of autonomous software engineering, an ecosystem where teams of specialized AI agents collaborate to manage the entire lifecycle of an application, from the very first idea all the way to deployment and long-term maintenance. And that leaves us with the ultimate question, right? If AI can handle the end-to-end process, ideating, building, testing, maintaining, what is the new role for the human developer? Well, our role is set for a radical transformation. We'll probably move from writing individual lines of code to defining outcomes, to being the architects, the conductors, and the creative directors for these incredibly powerful AI teams. That's the future we're all going to be building together very, very soon. Thanks for watching.